Today we're going to be presenting about how to use open source tools to serve AI and machine learning models on private infrastructure. It is going to be a hands-on slash some parts were recorded, but the most interesting parts are live. So first of all, we want to present ourselves. Who are we? My name is Saian. I work with Arcus Nexus, which is a software development company. If you want to take a look, we have a QR code at the end of the presentation. And
Yeah, I'm Vega. I'm also with Arcus. Been working there for several years. I work mostly on backend services, and for the past few years, I've been specializing in cloud computing and infrastructure. So that's a lot of this is that's from where it's coming from.
so the problem that we saw, or why we are doing this, is that a few months ago I asked a question to my friend Aaron. I am not a very technical guy, so I asked him, how can we implement a private and secure infrastructure to manage a local LLM, and that it doesn't require any cloud services, and that it's all open source and using open source tools and technologies. So Aaron gave me the talk about how Kubernetes and how we can use it. So what I understood is that it is very complicated to actually do that. And setting up a private infrastructure in custom environments is not easy. So that's why we came up with this POC. So the proof of concept objective is to simplify the process of setting up a private infrastructure within a custom environment. For this demo, everything is running in the local machine. And the use case that we are going to be showing to you guys is an image recognition app that helps us find tacos in YouTube videos. Why tacos? Because everyone likes tacos, right?
Yeah.
And
I want that. Just
go ahead.
So yeah, and we chose the image recognition use case because it's the simplest one. It's the hello world of the AI scene. So it helps us keep things tidy and easy to explain. So that's the reason. And also, no, you just go ahead.
All right, a little bit of high-level project overview. We're going to be using Ultralytics ULO V8 as the model for the image recognition. Label Studio for pre-processing and tagging our images. Jupyter Hub for the fine-tuning and, yeah, basically fine-tuning. And Docker and Kubernetes for portability and deployment management. So for those who don't know what Kubernetes is, go ahead, Aaron.
Yep, for sure. So yeah, Kubernetes is big lately, and if you don't know how it works, you can kind of assimilate it to a restaurant. Let's say we have a restaurant with multiple chefs that specialize in different kinds of cuisine, and each chef has to focus on just only the ingredients for that cuisine, for that style of cuisine, and preparing all the recipes that are according to that cuisine. And then if we have that scenario, we would need a chef manager that is looking up for the needs of all of the other chefs, making sure that they all have the appropriate ingredients for their cuisine, and also making sure ultimately that every dish is served according to the order that came in, right? So basically that's the job of Kubernetes in tech. We don't work with food, we work with the services. So basically Kubernetes is a manager for your services. It helps you with stuff. It helps you help check all of your services. So if you need to scale up or down, Kubernetes can take those decisions based on rules that you configure it to respond to. So yeah, we're gonna leverage Kubernetes to make this workflow work. The YOLO workflow, it's pretty simple. It's essentially 3 steps. Just pre-processing your data set. In this case, data set is a set of images, tacos, and then we will use Label Studio to tag those images in order to indicate to the model which object it needs to identify. So that's the first step. The second step, we're going to be using Jupyter Notebooks to fine-tune the YOLO V8 model. Basically just running the training API of that Ultralytics provides, taking it from our data set. That way we can specialize our model to find tacos, right? And lastly, we're just gonna serve a small application that you can input a YouTube video, and it will process that video, find all the tacos in the video, and ultimately mark them up in the video. Uh, so the tools that we're using, we mentioned some of the high-level tools, but these are the behind-the-scenes tools. We're going to be leveraging Docker and for containerization and portability. All of our tools are going to be running inside containers, which is the way that Kubernetes needs their services in order to be deployed and used. And then for the infrastructure, managing the infrastructure, we're going to be using CDK 8, which is similar to CDK from AWS. I don't know if you're familiar with that, but that's basically just infrastructure as code. You can manage all of your infrastructure instead of using YMLs, CloudFormation manifests, and all that. You can use code. And CDK 8 works pretty much in a similar way, just specialized for Kubernetes manifest instead of AWS's. And lastly, we're going to be using Helm. That's just a package manager for Kubernetes. Basically, it allows you to bundle a bunch of tools into a single package that you later can install as a single unit in your cluster. So yeah, the setup that we have here, we have already skipped ahead some steps because just in the best interest of our time. It is all that you're going to be seeing here. It's already streamlined to a proper amount of time. But these processes take a lot of time because a lot of these images are on the gigs. So downloading them and installing them into your cluster, that's a slow process. So keep in mind that whenever you try this, it's going to take a lot more time than we're going to take here on this presentation. That's also the reason why we already set up some parts of the cluster and we didn't do the whole thing live. So yeah, basically the first step for our project was setting up a cluster, and we needed a couple of tools for that. Since the point of this project was running the workflow in a private infrastructure, whether that be because you have privacy concerns or because you only want like a quick lab kind of setup or something smaller. That's some of the reasons why you would need to do this. So some of the components apart from CDKs is the load balancer and the GPU operator. Those are core for running in your custom hardware. If you run this project in a cloud provider, you don't have to worry about those components because the cloud provider already takes care of them. It's already set up. You basically just spin up your cluster, and it already has access to the GPU if the cloud provider allows that. But we're going to be setting those up manually in our case. Now, for this demo, I've already went ahead and set up the GPU operator, which you can see it's a bunch of services. And the ones that we care are this lot over here at the bottom, especially the daemon set. That's a daemon set that's running inside the cluster that can talk to the hardware on the computer, so we can make use of the GPU in order to either train or serve the image recognition model. Similarly, I've also set up a load balancer, which I can. Yeah, it's this one. Load balancer, it's pretty simple. It helps you manage traffic incoming to your cluster, and it also tells or allows Kubernetes to know when it needs to scale down or up or allocate more resources to your services in case it's needed, right? And as I mentioned, if you're running in a cloud provider, you don't really need to do this. But if you want to make a point of running into your own hardware, you're gonna need to set it up. So basically that's it, and yeah, this is some of the parts that we already pre-recorded. This here that I'm playing, I'm just setting up the same environments, the same components that I just mentioned. I'm first creating a Kubernetes cluster, and then I'm gonna install first the load balancer and then the GPU operator. And keep in mind, this video I'm gonna actually skip ahead, even if it's short. It's about 2 minutes long, but this process takes about from 15 minutes to half an hour. So be mindful of that. Just because the GPU operator sometimes takes a while to spin up and recognize the hardware. But essentially we are just going to apply some uh, of the files that we already have in the project. Yeah, actually I missed that part. I'm sorry. All of these that I'm going to show here is in a public GitHub repository that we're going to share at the end. So please keep an eye out for the link. And that repository has also a README, which is documenting all the process of setting this up from scratch, and also it includes a branch which is called Start From Here, which you can check out and start from scratch. Basically, you already gonna have the load balancer and the GPU operator, but basically you can use that branch to bootstrap your own lab. So yeah, that basically is just running a bunch of commands. There are some workarounds as well, because we are using Kind. Kind is a development cluster for Kubernetes, and it has some issues with hardware. So we had to find a workaround for that. That's the Docker modification that we're doing here. Basically, we're just modifying or creating a symlink inside some of the containers in the cluster in order for them to be able to see the hardware. Sorry. Okay. Yeah, I actually. No, it's in the other tab. Okay. So the next step, once we have that's basically a bare bones Kubernetes cluster. What I just showed you, just setting up the cluster. Now we need to add our tools that we're gonna need for our workflow, and we do that using Helm charts, as I mentioned earlier. That's just a simple, not a simple. A package manager for Kubernetes that allows you to bundle up different tools into a single unit. So the two tools that we're going to be using are Label Studio and Jupyter Hub. I'm going to show you some code, and I'm going to try to, I didn't open the code, so. Oh, sorry, is that better? Yep. Like that? Okay. Okay. So yeah, the first thing that you're gonna notice if you follow or read me is that once you bootstrap your project, it already has an infrastructure as code folder and with some files. These are basically the files that CDK8 generates by default when you start a project. I just added a couple more files to handle the infrastructure that I was just talking about, the load balancer and the GPU operator. But CDK8, in order to allow us to create things, has the concept of charts, which are similar to Helm charts, but not quite the same thing. With CDK8's charts, you can define your own constructs that are going to be applied to your cluster afterwards. So basically, you code all of your infrastructure. You run the synthesize command, and that generates a bunch of YML files that you need to apply to your Kubernetes cluster. The advantage of this is that it's way easier to manage. It's way less code, and effectively you can also reduce the need for DevOps engineer, because this allows developers to also step into the ops realm. So because it makes it more easy for them to manage, and they are familiar with code. So yeah, the thing this way works. The way CDK8 works is that we need to create one chart where or multiple charts with the resources that we want to install into our cluster. What I'm defining here is an AI chart, which I have added two Helm charts, which are Label Studio and Jupyter Hub, and I want to install those into my cluster. Uh, all of these are documented on their respective uh, home pages or their documentation pages. Jupyter Hub has a Helm chart, and it provides all the parameters that you can pass into the Helm command, which are the same that you can tweak here under each of these props for each of these Helm charts. So how does that look? Once we have ready, we have our sorry. There we go. Once we have our code ready, the only thing that we need to do is run the synthesize project, the synthesize command, I'm sorry. That's the thing that generates the YML files that Kubernetes needs to know what it needs to run. So basically, we have two files here, well, three files. Two are from the previous infrastructure components that I was mentioning, and the last one is the one that I just compiled, which contains the Label Studio and Jupyter Hub. And once it creates, once it creates that, you saw that we also ran the kubectl apply command, which is the command that actually installs it into your Kubernetes cluster now. So if we want to see the state of that cluster, is going to be, oh, sorry. So yeah, basically this namespace contains all of the tools that I have installed into that chart, that particular chart that I was showing, and the outcome of that is that again, it spins up the services for both Jupyter Hub and Label Studio, but it takes a while to become completely green. So be mindful of that. But once that's done and you can see that everything is running fine in your cluster, you can go ahead. Oh, actually no, I almost missed that. You can go ahead and check out under services. Both of these Helm charts create a service that exposes that particular application to traffic outside the cluster, and you can check those in here. So basically, for Label Studio, we have this external IP. Oh, where it is? Oh, here it is. So this external IP, which if I go into the browser, open a new tab and go into that. What's going on? You can see that we have our Label Studio instance running, right? And the first time that you come into Label Studio, it's going to ask you to create a profile. Since this is a local setup for the moment, it doesn't really matter what you input here, but you're going to need to create a new. Oh, no, it's already created then? Yeah, yeah. Come on. There we go. So yeah, once in Label Studio, what we want to do is create a new project. which is the construct that that Label Studio uses for us to upload our data set. So in this case, I'm just gonna do some name it tacos, since that's what we're gonna be doing. And here, once you have your project set up, you can import your data set. You upload your files. I already have it ready here. So you just, oh, sorry. How many images? Yeah, that's a small data set. That's not a, yeah, yeah, that's around 40 pictures. So yeah, but the real data set that we trained the model with, that's about 1,000 images. So yeah. So before you start tagging your images, it's gonna ask you to set up your project, which is obvious. So since we're doing YOLO, we want. I mean, we can choose from several of the templates there, but the one that I'm using is that simple square tags. So it already comes with a template. I'll just need to replace the provider labels, create a new one. You can create as many as you want. For the demo, I'm just gonna create a single one, so I can we can see the proof of concept. So once you save that, did it save? Yeah, I think so. You can go back into your data set and start processing. We already see that we have here our tacos label down here, which is something that we want to use to tag images. But in this first image, we don't have any tacos, so we're going to just skip it and go into the second one, and just select this label here, and then we can just, you know, tag it like that, submit the frame, and you know, you get the idea. You have to do this a bunch of times until you no longer wish to work on what you're working on. So yeah, once you have done all of your oh, sorry, that's not it. All of your data set, you can export it, and the reason we chose Label Studio for this demo is because it allows us to export it in multiple formats, but especially the YOLO format, which is what we needed to make it work with YOLO V8. So you can export that and should download a zip with all of your images, all of your label data, and all of your tag data as well, the coordinates in which the images are tagged. Now, yeah, once we are done with that, we can jump into Jupyter Hub and fine tune all our model. So let me show you also how we do that. However, this is also a very time-consuming process. So we already have it. We ran this like 2 hours ago. Basically, within your Jupyter notebook, it basically spins up an isolated pod inside your cluster your Kubernetes cluster. So you can install all of your dependencies in there. You can have multiple users having multiple you know, pods of their own, you know, or having multiple users access the same pod, so they can work in a collaborative manner. And all that kind of stuff. So yeah, we basically, what we did here was just install the Ultralytics dependency, and once that was installed, we just ran a small, you know, we just ran 3 epochs just as a proof of concept, but we are running this in our Kubernetes cluster in our local environment. Sorry. Okay. That's for the training part of the workflow. But once we have all that done, we also may want to serve our model or make it available through some application or service or whatever, right? And the process to do that with Kubernetes is a little bit it's both straightforward, but that doesn't mean that it's easy. All you need to do is create a Docker image and publish it into a registry, whether that be private or public, that's up to you. But Kubernetes needs those images in order to pull them and spin up new pods according to your indications, right? Uh, so our application is basically just a wrapper around. Let me just. It's basically just a wrapper around the YOLO V8 API. YOLO V8 provides a pretty neat API to either keep training your model or just predicting or inferring stuff from images from video or images. And all I had to do was just wrap that around an application that received requests either to start a session or to start predicting. So and all of that is contained in a Docker image that we can see the definition here. We're just building the application, which is fairly simple. You can look it up in the repository. But the important part here is that we need to use the Ultralytics image because that contains the tools to interface with the YOLO V8 API. You can do that with Python, which is easier. We kind of experimented here, and we did a Go application that kind of interfaces. It's kind of gimmicky, but it proves the point. So that's the reason why we wanted to do it that way. So yeah, basically you just need to use your Docker image. Once you have it, you can build it and publish it into your registry, and the way that we're gonna use it in our project is we're gonna add it into our same chart. You can add it into a different chart, but I'm gonna use the same one. And the first thing that we want to do is set up all the registry secrets. These are Kubernetes secrets that we need to create in order to tell Kubernetes the credentials for the Docker registry that we're gonna be using. Otherwise, it's not gonna be able to download those images. So we did do that. We're using basically the same environment variables that Docker login persists in your system. So if you've done a Docker login in your machine, you can use this code as it is, and it should work for you as well. So we not only need those secrets, we also need to tell Kubernetes what to install. So the first component that we're gonna need to do or to specify is a deployment. And a Kubernetes deployment is basically, I don't think I showed, yeah. So a Kubernetes deployment is basically you setting up a bunch of specifications about your app, which image you want to run, the environment variables, and scaling rules, all that kind of stuff. You can set that up in your development. You have a pod spec here which you can modify the same way that you would in a YML file, but you can do it directly in the code here. So the deployment is the application itself. It contains the image that I was just showing you the Docker file for. But as I mentioned, we also need a service for the application to be available outside the cluster. So I'm also adding a new service, and what is important here is that we need to tell the service which port to redirect traffic to. So basically, I'm using port 8080 in my application. I need to set up my target port on my service to be the same as my application. Otherwise, it's not going to throw any errors, but you're going to be scratching your head, wondering why it doesn't work. So yeah, again, if in the README I go almost line for line explaining what each of these lines do. So if you have doubts, we have questions at the end, but you can also take a look into the repository. Right now, I'm just gonna compile it again. Let me see. And I'm gonna apply again, but only the last file, which is the only one that I modify, the one for our AI infrastructure. I didn't modify the other ones, but it doesn't really matter. As you can see, right now when I'm executing this, you can see that CDK8 is capable of identifying if any resources have changed against your cluster, and if it hasn't changed, it won't apply any other changes to that. It will just roll out the new changes to your chart. So yeah, what that did is that we should see a new pod in our cluster. Here it is, which it started like 20 seconds ago, which is the container for our demo application. 172. This one should be. Oops. Which is our FAME tag finder. I'm just gonna pass in a YouTube video. I have the logs here, which has already started running, but you could also monitor that directly on your pod, looking at the logs. I don't have the lens metrics installed in my cluster, so I'm not able to see them. But you can do a kubectl as well in order to see that. So yeah, if we check at the logs, it hasn't detected anything yet. But what this is doing is, first it downloaded all the video from YouTube, and that gets passed into the Ultralytics API. Internally, Ultralytics they split up the video in frames and analyze each frame individually to find the object of interest, right? So yeah, we have some found, some hits here. And this is also something that takes a little bit of time. It can be improved a lot if you pre-process your video. So for instance, instead of passing directly the video from YouTube, we do some pre-processing and maybe modify it to say 20 frames per second. The prediction time it becomes lower. It's quicker. But for now, it's going to take about 3 or 4 minutes, and yeah, you can see that it's running. Where is it? Yeah, it's running on the GPU directly, and it's running from our Kubernetes cluster. So yeah, basically that's it. Don't know if you want to add something else. Let's just give it some minutes to finish. We can check out the result.
Time while we are waiting, do you guys have any questions or something?
Okay, gotcha.
I'm more curious, where do you find all these, like, you strung together a lot of different pieces? It's just sort of trial and error, or there's certain resources you reached out to for?
How do we find all of these tools and?
Yeah, the tools, and you don't show the contents of some of these files you've applied for the cluster, but.
Yeah. There's a repository for help charts which you can look up. But I was already familiar with both Jupyter Hub and Label Studio, so I was aware that they had help charts provided for Kubernetes. So I would say it's a mix of experience and research, because once we settle on the proof of concept that we wanted to make, we also had to do some research to see if which model was the one that fit best for project, and if the tools that we had already selected were the right ones. The Kubernetes part is that's experience. I've been working with infrastructure for over 5 years now, and mostly doing Kubernetes. So the thing that we didn't mention is Saian came to me because he's working with a customer that does AI stuff. There's actually like a personal assistant. They have a booth around, but he wanted to simplify. They have some concerns. They need to run into custom hardware or more a local setup, and we started looking from there. How we can accommodate that and make a proof of concept. Researching the tools, researching the methodology. As I mentioned, it wasn't as it was straightforward. It wasn't easy because there were so many workarounds that we needed to weed out. But yeah, it was. We did a bunch of research at the beginning. We had a lot of experience, but ultimately we had to also, trial and error a bunch of stuff. So I would say it's a combination of all of those.
Is the model selection mostly just you have some pictures and you run through this process and then see if it spits out what you expect, or?
Oh yeah, you mean the fine-tuning process, right? So yeah, basically, once you can run this is an iterative process. So you run your training several times, and the output from YOLO is these checkpoints, these weight checkpoints, which tells it gives you the last iteration that you ran, and also the one that had the best results. So you can pick up the one with the best results. And how do you know which one had the best result, right? So how do you know when to throw out some result from your training or not? You have to monitor I believe this is the average precision, median average precision. I think that's the name of this stat here. This should increase over time until you reach your desired accuracy. So for this demo, we just settled for around 75 to 80% accuracy. So we train our model until this value here came close to that value. I don't know if that answers your question. Yeah. Okay. On the back. Yeah. Well, no, that's kind of like a quirky choice that we made because we just wanted to experiment. And actually, the only Python that we use is this script here, which is just telling YOLO VA to, hey, we need to train again. So that's it. But our Go application uses the CLI actually, the YOLO VA CLI. YOLO VA also has a CLI which you can use on your local system if you don't want to set up this kind of stuff. So let me see if this is ready. Yeah. So here's the result, right? So it's not perfect. As I mentioned, we are aiming around a 75 to 80% accuracy. It gets confused sometimes, but overall it works. And by the way, Habaneros is not a sponsor in any way, but shout out to them. I hope they're doing great. So do we have more questions? Yeah, over here. Yeah.
I don't know how long.
Yeah.
And your API will just not work.
Yeah. Basically, that's I believe, I'm not 100% sure, but that's a partnership kind of thing. Ultralytics provides that part of they handle it internally, so we just pass the link and they download the video on their own. So yep. That's like an API, right?
Sorry.
Yeah. Oh, okay.
So you could use that, or just there's an excellent plugin for Firefox. His name skips my mind at the moment, where you can download a video.
So the question was, how do you get YouTube to let you have videos that's not annoying, full of ads manually, and the endpoint changes?
Yeah, and also I think they limit the rate of.
And the answer was that the yellow thing that you're using seems to have a deal or something?
They seem to use some sort of API over here. I think it's this one here. Yeah.
Do we have other questions? Is it question time?
Yeah.
We're at the question period?
Yeah.
We saw the tacos.
Thank you for your talk.
the CDK8s, that's not a substitute for kubectl at the command line, because I saw you using it for setting it up. So you still use kubectl to communicate, and it's just adjusting. You still use kubectl and YAML files. I thought you said before it was a substitute for those, but I guess you still use them, but it's controlling the Helm
helps
charts
you
and it's
manage,
controlling the back. So, okay.
Yeah,
Is that, do I have that right?
Yeah, exactly. So the question was that if the kubectl is still relevant while using CDK8s. But yeah, it is, because the output of CDK8s is still YML files that you need to apply to your cluster. But if you use CDK8s alongside CDK, which the AWS CDK, those two are interoperable. You can invoke CDK8 shards from CDK, and they will execute. So you don't need kubectl on that scenario. But for the rest of the world, we just have to deal with it. We had some more questions.
Yeah, I was just curious what GPU you have in there.
GPU, that's GTX 3070. Oh yeah, actually yeah, it's yeah. Yeah, we were looking into that, but we couldn't get one in time. So yeah. Do we have?
You said you had a like a walkthrough tutorial or something?
Yeah,
like
yeah.
Full
oh,
instructions?
actually, I haven't shown you the last. Sorry for this. So yeah. You can check out the repository over there and give us a follow on Arcus Nexus.
There we go. Now we got a lot of phones up taking pictures. Any other questions?
Over here. Yeah, for sure. It's more. Yeah, it's missing those. Yep.
So my question is, have you actually considered using operators to kind of automate some of the things that you just did today? You could just like run them in the cluster and just feed the models into them and get the results. That's
Run
faster.
operators?
Kubernetes operaters.
Oh no, actually I haven't looked into that, but yeah, that's
makes
a
it
good,
faster.
That's a good point. Yeah.
You can natively run them. Yeah.
Yeah. Over here in the front.
I'm taking the long way around, getting my steps in.
So it looks like GPU operator is doing a bunch of the heavy lifting for the NVIDIA setup, right?
Yep.
So you're on a single node box because you're just running on your workstation.
Yeah.
Does it auto-detect which nodes have
Yep.
NVIDIA? And do you do something in your deployment to say which nodes to schedule to?
Yep, that's a good point. I can show you right over here. We have, we have some files for cluster definition. This is specific for kind, but you would have to do something similar for either bare bones Kubernetes or any other cluster provider. But yeah, we are telling it here, creating those files in the mounting rather into the containers. So those are the ones that allow the nodes to talk to the GPU. So.
All right, big round of applause for Aaron and Saian.
Thank you.